Ever wondered how Honda engines deliver both efficiency and performance? The secret lies in a technology they developed called vtec. If you're a car enthusiast or just someone interested in the magic of automotive engineering, you've likely heard of Honda's vtec. This ingenious technology, short for variable valve timing and lift electronic control, was first introduced by Honda in the late 1980s and has since become a defining feature of their engines. But what exactly is vtec and how does it work? In essence, it's a variable valve timing system designed to optimize the performance of internal combustion engines. That's a mouthful, right? But don't worry, we're here to break it down for you. The basic idea behind vtec is to alter the timing and lift of the engine's intake and exhaust valves to enhance performance across different RPM, or revolutions per minute ranges. This dynamic alteration of the camshaft profile allows an engine to perform like two engines in one. Yes, you heard that right. Two engines in one. At lower RPMs, the engine behaves one way, focusing on fuel efficiency and smooth operation. But as the RPMs increase, the engine switches gears, so to speak, optimizing for high power and performance. This transformation is achieved through a dual camshaft profile. Each valve in a vtec engine has two sets of lobes on the camshaft. One set is designed for low RPM operation, with a shorter valve lift and duration. The other set, designed for high RPM operation, features a greater lift and longer duration, allowing more air and fuel into the combustion chamber, ideal for higher engine speeds and power output. The magic of vtec lies in its ability to allow an engine to behave like two engines in one. It's like having the best of both worlds, efficiency when you need it, and power when you want it. And that, in a nutshell, is the brilliance of Honda's VTE. Let's dive into how the vtec system works. A key player in the vtec system is the engine's camshaft. The camshaft is essentially the conductor of your engine's orchestra, dictating when the intake and exhaust valves open and close. In a vtec engine, the camshaft has two sets of lobes for each valve, each composed with a different performance in mind. The low RPM lobes are all about fuel efficiency and smooth operation. They have a shorter valve lift and shorter valve duration, perfectly suited for lower engine speeds. Imagine them as the economy mode of your engine, saving fuel and ensuring a smooth ride. In contrast, the high RPM lobes are the powerhouses. They have a greater lift and longer duration, allowing more air and fuel into the combustion chamber. This is ideal when the engine speeds up and more power output is required. Think of it as the sport mode of your engine, ready to deliver that extra punch when you need it. Now, the magic of vtec lies in its ability to switch between these two sets of lobes. At lower RPMs, the engine uses the low RPM lobes, optimizing fuel efficiency. But as soon as the engine speed reaches a specific threshold, typically between 4,000 and 6,000 RPM, the vtec system springs into action. This switch is controlled by engine oil pressure, a hydraulic actuator, and a control system. When vtec engages, a locking pin connects the high RPM camshaft lobe to the valve's rocker arm. This switch causes the valve to follow the higher lift and longer duration of the high RPM camshaft lobe. As a result, more air and fuel are allowed into the combustion chamber, and the engine can generate more power. In essence, the vtec system is like having two engines in one. It's capable of switching between fuel efficiency and high power output based on the engine's speed. So whether you're cruising down the highway or zipping through the city streets, your engine is always optimized for performance. The vtec system essentially switches the engine performance based on RPMs, balancing efficiency and power. So, what does vtec bring to the table? Well, the primary benefits of vtec can be categorized into three major areas: efficiency, performance, and versatility. Let's delve into each of these to understand how vtec truly enhances the driving experience. Firstly, vtec contributes significantly to fuel efficiency. At lower RPMs, the engine operates with a shorter valve lift and duration. This means that less fuel is needed to maintain engine operation, resulting in a more economical ride. So while you're cruising around town or stuck in traffic, your vtec engine is working hard to keep your fuel consumption as low as possible. But vtec isn't just about saving fuel. When it's time to let loose and enjoy the open road, vtec shows its performance side. As the engine speed increases and the vtec system kicks in, the engine switches to a camshaft profile with a greater valve lift and duration. This allows more air and fuel into the combustion chamber, leading to higher power output and a noticeable surge in acceleration. With VTEC, you're not just driving, you're truly experiencing the thrill of high-speed performance. Lastly, let's talk about versatility. VTC essentially allows an engine to behave like two engines in one. It offers the fuel efficiency of a smaller engine at lower RPMs and the performance of a larger engine at higher RPMs. This dual personality makes VTEC engines remarkably adaptable, ideal for both city driving and spirited highway cruises. In essence, VTC offers a balanced driving experience, seamlessly transitioning between efficiency and performance based on your driving demands. It's an elegant solution that lets you enjoy the benefits of both a fuel-efficient engine and a high-performance motor without having to choose between the two. VTC delivers the best of both worlds, making no compromises. Over the years, Honda has not stopped innovating. They have developed different variations of vtec, each with their own unique features and benefits. Let's dive into some of these variants. First up, we have the iVTC, which stands for Intelligent Variable Valve Timing and Lift Electronic Control. This system combines the classic VTEC with Variable Timing Control, or VTC, allowing for variable timing on the intake camshaft. The result of this combination is an engine that performs optimally across an even wider RPM range. The iVTC system allows for seamless transitions between low and high-speed operations, ensuring maximum power and efficiency at all times. Then there's the VTCE, the E standing for economy. This variant takes fuel efficiency to a new level. It employs an economy-focused camshaft profile and incorporates lean burn technology, which allows the engine to operate with a leaner air-fuel mixture. This translates into less fuel consumption and lower emissions, making it a great choice for environmentally conscious drivers. Lastly, let's talk about DOHC and SOHC VTEC systems. DOHC stands for Dual Overhead Camshaft and SOHC stands for Single Overhead Camshaft. These refer to the number of camshafts used to operate the engine's valves. A DOHC VTEC engine has two camshafts, one for intake valves and one for exhaust valves, allowing for more precise control over valve timing and lift. On the other hand, an SOHC VTEC engine operates with a single camshaft, making it simpler and more compact. While DOHC VTEC engines are commonly found in high-performance vehicles, SOHC VTEC engines are often used in everyday cars where simplicity and efficiency are key. Each of these VTC variants has its own unique benefits and applications, and they all showcase Honda's continuous commitment to optimizing engine performance. Whether it's power, efficiency, or a balance of both, there's a VTEC system designed to deliver. These variants show Honda's continuous commitment to improving engine performance and efficiency. VTEC is not just a concept, it's been applied in various real-world applications. This ingenious technology has been incorporated into a multitude of Honda and Acura vehicles, ranging from high-octane sports cars to the everyday machines that get us from point A to B. Take, for instance, the legendary Acura NSX and Honda S2000. These high-performance sports cars have been the poster children for VTC, showcasing how the technology can deliver exhilarating power and performance at high RPMs. Whether you're taking on the track or cruising down the highway, these vehicles utilize VTEC to provide a driving experience that's both thrilling and efficient. But VTEC isn't limited to just the performance realm. It's also found in more everyday vehicles like the Honda Civic and Accord. These models use VTEC to strike a balance between fuel efficiency and power. What's more, VTC has even made its way into the world of motorcycles. Honda's motorbikes use the technology to deliver a smooth, responsive ride, whether you're navigating city streets or tackling winding country roads. It's a testament to VTEC's versatility that it can be applied to such a diverse range of vehicles and driving scenarios. But the applications of VTEC don't stop there. This technology has also been used in power equipment, such as generators and lawnmowers. Even in these machines, VTC plays a crucial role in optimizing engine performance, ensuring they run efficiently and effectively. In conclusion, VTC has proven its versatility and effectiveness in various applications, truly standing as a defining feature of Honda engines. From high-performance sports cars to everyday vehicles, motorcycles, and even power equipment, VTEC continues to revolutionize the way we experience engine performance. It's not just a concept, it's a real-world solution that's changing the game 1 RPM at a time.